Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all. Welcome to our 18th session of webinar, Leaders of Enterprise, brought to you by the Faculty of Engineering, University Technology, Malaysia, Johor Bahru. So we are initiating university, industry, collaboration, networking, and as a platform with our leaders from industry to share their thought, way forward, and challenges in the industry, and also collaboration with the university, especially during this COVID-19. To all, now we are streaming live from Facebook Faculty of Engineering, University Technology Malaysia. So today we have a special guest. We would like to welcome Engineer Ismail Musa, Head of the Mechanical Rotating, Principal Engineer, Petronas Refinery and Petrochemical Complex Utility Facility. Please welcome Engineer Ismail Musa. Assalamualaikum.
Waalaikumsalam warahmatullahi taala wabarakatuh. Ya, Prof.
Welcome.
Fahmi.
Welcome, Engineer Ismail Musa. You looks good
Yeah,
today.
Yeah, most welcome also to you.
Thank you so much, Ismail, for accepting our invitation toward the end of the year. So we managed to grab you. Beside your busy schedule and busy time, Engineer Ismail. Yeah. So to all viewers today, Engineer Ismail will share with a very interesting topic related to Petronas Rapid. So he will be sharing with us a talk entitled "The Making of Rapid Plant." So later he will show something, some presentation, also video about the rapid plant. After that, we have something to talk about, and maybe we can hear a few questions from audience. Yeah, Engineer Ismail. Yeah. Okay, Engineer Ismail. Before we start, welcome again. And I heard that you are the alumni of UTM. When were you graduated, Engineer Ismail?
Yes, very long story, Prof. Because
Yeah.
almost 20 years I'm in the industry.
20 years in
after
the
after graduated from UTM in year 2000.
year
Yeah.
2000. All right. It's been long. Yeah.
Yes. So this year is the end of my year of 2000, like 20,000 lah, almost in the industry.
Oh yeah. 2020. Right.
Yeah. 2020, yes. Yes.
So you studied in UTM KL campus or UTM Johor Bahru campus?
A lot of my time, in UTM Skudai, yeah, previously. Yeah, right from 1996 until 2000 lah.
Yep.
Yeah.
So where your hometown? Where you from? Maybe you can share a little bit about your life, your family, Engineer Ismail.
Yeah, thank you, Prof. First and foremost, I would like to thank UTM lah for inviting me to share some of my experience in industry so far. So actually, I'm from Jitra, Kedah, yeah. But right now, I'm in Johor Bahru, yeah, serving the Rapid, yeah, very close to UTM Skudai. Yeah. Actually, after my school time, I spent my study in UTM for about 4 years. Did my degree in mechanical of engineering, pure mechanical engineering.
Pure mechanical. Yep.
Pure mechanical, yes. And then after that, when I graduated from UTM, I've been offered to join Petronas straight away because I'm a Petronas scholar from beginning.
Wow.
So I straight away joined
I
Petronas after
see.
I graduate from UTM. Kan?
Ini
And
Ismail, not
yes,
many got this Petronas scholarship. They must be special with your SPM MCE result that you got this scholarship.
my SPM result is not so good, kan? That time I only managed to get about 18 aggregate that time because
Okay.
I have a lot of story behind, yeah.
Mm-mm.
Uh, when I sit for trial tu, I got very good result, yeah.
Trial.
But
Yeah.
before the real exam, SPM exam tu, my mother passed away, you know. Today my father passed away. Tomorrow I sit for the SPM. So a bit that time a bit challenging for me lah to focus at that time.
Yeah. Probably
So,
a bit
but
stress as
I
well.
alhamdulillah to get I be here today, yeah.
Yeah,
At
God
least
will. Yeah.
Allah bagi kat saya kan. So
Mm-mm.
that's why I be here lah in Petronas until today. Still loyal to Petronas lah.
Petrona would like to hear that actually.
Yeah. And then after I complete, I been assigned in Kuala Lumpur, KLCC
LCC.
for 3 years as a construction engineer that time. They offer me as a construction engineer to oversee the pipeline project. Yeah, from that time from Trono, from UTP tu, right?
Yeah.
Setiawan that time.
Oh no, to
So a lot of
Setiawan.
experience
Okay.
lah. Masuk hutan, keluar hutan kan, masuk sungai, keluar sungai. So
Wow.
a lot of technology that we involved that time. And then I come back to Kuala Lumpur, KLCC. And then I asked for a new experience lah in plant pula kan, in
Yeah.
plant
Plan. Yeah.
engineering and so on. Yeah. Then I request to my boss lah, boss, I want to go to plant lah. I want to learn the new things in plant, plant process, so on. Then with 1 month notice, so they give me the chance to go to Kerteh lah. Then I spend most of the time in Kerteh,
Since
about 18 years. Yes.
18 years, Kerteh. Yeah.
So 3 years in Kuala Lumpur, and then until 2018, not 18 years lah. So maybe about 15 years in
15 years.
Kerteh.
Yeah.
15 years in Kerteh. Spend my life there in Terengganu. Jumpa pula orang Terengganu, kahwin dengan orang Terengganu.
Okay.
That time, yeah. So
Almost settled down, right?
almost settled down in Terengganu, yeah. But that time, Petronas offered me lah to go to higher level, to principal level, yeah,
Principal level,
specialist level, yeah, because I spent a lot of my time, focus on engineering, turbo machinery, rotating. Then I sit for external examination, organized by Petronas. Then I pass that examination. Then Petronas wants to promote me lah. Then they offer me to MLNG Sarawak at that time. But I said,
Sarawak, yeah.
I said to Petronas, come on Petronas, give me a nearest location lah to me, to my hometown. Kan? So then finally our VP there, EVP now, Encik Arif, Datuk Arif, gave me the opportunity to involve in the rapid at the time. Then I was to rapid in 2018 until today lah.
Until today.
Yeah. So, on my education background, when I spend a lot of time in industry, on engineering, on process, on maintenance, then I request for masters in UTM that time. I did my masters in UTM also.
Further your study, masters.
Further my study in masters, masters of engineering in UTM, particularly on vibration area that time. With Prof. Dr. Rahman that time.
Dr. Rahman, yeah.
And Prof. Rahman and Salman Leong, yeah, that time. And then
Both of
this
them
year,
already, yeah.
yeah. I think both of them already retired.
Rahman, Prof. Rostan Rahman, and Prof. Salman
Yes,
Leong.
yes. And then I believe they are still serving the industry.
Yeah, industry.
Expertise to industry, especially Petronas lah. So I know their involvement in this industry lah, particularly.
So meaning close to UTM, Engineer Ismail.
Yeah. Okay, during my career progression juga, I sit for exam for professional engineer, Prof. Professional engineer. Then I been appointed as a professional engineer in year 2007 that time. 2007 and until today lah. Then along the way, I also involved in internal combustion engine. Then I sit for DOS examination and I passed the examination. Now I first grade holder lah for internal combustion engine. And also in career also, I also adjunct lecturer lah in few universities, like for example in UTP, in UMP, University Malaysia Pahang, UMP, and also UATM.
Okay. So is it okay?
Belum ada.
We invite you as adjunct professor later.
Inshallah, if you give me opportunity, then I will do my best. To give my experience lah to my beloved university.
Thank you, Engineer Ismail. So is that all about your biodata? Brief biodata.
Yes.
To all viewers today, we know that Engineer Ismail is spending a few years in Rapid Petronas in Pengerang. So today he will be sharing with us his experience with this development of Rapid. So without further ado, I think I pass this session to Engineer Ismail to share with us with your title today, the Petronas Refinery Petrochemical Complex Facility. Please, Mr. Engineer Ismail, over to you. The making of Rapid Plant, right?
Yes. Inshallah, I will share some of the activity lah in the Rapid project. So in my yes,
you will start with showing some videos with us, or something like that.
Yes. So in my presentation or sharing experience, I will share two main area. One is the video on the Rapid construction that time from the beginning, from the empty space right to the world-class punya facilities. And also the second part, I will share on some of the my area of responsibility in Rapid, and also some, maybe we can chit chat some of the experience troubleshooting and so on in this plant. So now I share the video. Maybe you can have a nice experience throughout this about 8 minutes time to complete the video, and then after that we continue with presentation. So I share now the video.
Once an impossible dream. From a challenge to a greater challenge. From a success story to another success story. A proven of hard work, determination, and superior teamwork. For a dream become a reality.
Okay, everybody still with me? Prof, are you hear me?
Cik Ismail, slide-nya dah on ke slide?
Okay. Okay. This second slide that I want to share with all of you. Hopefully you are enjoying the video explaining the overall refit plan right from beginning until commissioning time. So this is the second part of my presentation. The overview of PRPC UF asset, in which I'm taking care the some of the area in these facilities, particularly on the utility facilities. This is my presentation outline. I would like to share some of the information that we have. One is the rapid overall site layout and also execution package. Project information and progress. So it divided by package. So now package 14. And the third one, the brief project information and progress. And on the number 4 is on the raw water treatment plant, which is under package 16B. And some of the package 12 and also PAME. Yeah. This is overall rapid site layout as shown in the presentation slide. The one that I highlighted in yellow is on the utility side. The one in the still in the black color is in focusing on refinery, steam cracker, Petronas chemical, and also some of the tank, refinery flare, and also tankage. And for G, PCP is under Penggerang Cogen plant, ASU, separation unit, and also solid handling. Okay, as you can see from the slide, so the area of coverage for Petronas Rapid is about 7 kilometer times 7 kilometer overall. Okay, the project description, the main package for utility facilities is package 14, which is utilities interconnecting and offsite facilities. Also the package 16, A and B, with regard to effluent treatment plant, which effluent treatment plant is to provide a specific treatment of runoff water and effluent from all sources in rapid project. So its purpose is to reduce the pollution below the required discharge limit and meeting the statutory requirement from government. For package 16, raw water treatment plant, which is raw water treatment plant provide the treated water to overall rapid complex. Okay, the treatment process is based on the inlet aeration, standard clarification, including coagulation, flocculation, and settling, and also filtration. Additional treatment for silica removal and disinfection, including additional of free chlorine in the treated water and UV sterilization. Yeah. Okay. For package 12 and A and B is for product warehouse. So here we are packaging, we do the packaging, bagging, and auto storage system for petrochemical product. Solid product jetty, we after the product complete package and bagging system, then this product will be exported. Yeah, be export through this jetty. And also we have the cogen plant, itu cogen plant, Pengerang cogen plant is to generate the power and also steam. So this power they are producing is about 1,400 megawatt to the rapid plant. And some of the power exported to TNB as per agreement between Petronas and also TNB. For the steam generation, we are producing about 1,250 ton per hour steam just for rapid consumption. Yeah. Okay, some project information about the package 14, which is the main package for utility and interconnecting between the plant, between the utility and also the main plant, which is a refinery and also petrochemical complex. So overall function of utility facilities, basically their function to generate and distribute utilities. Number two, we also receive and distribute facilities. For example, for generate and distribute, we have treated water system, and we have plant air and instrument air, and also emergency power system. Okay, for the receive and distribute utilities, we have nitrogen and oxygen. We are also producing electricity and fuel, steam and condensate, and also some of the chemicals. For users, we have our users for utility product. We will supply to overall rapid customer, namely refinery, the steam cracker plant, and also petrochemical complex. And also we also supply to the users, for example, offsite and non-processed area, and PCP and ASU. ASU unit is a joint venture between Petronas and also Gas Malaysia to produce the oil gases. And also our other users, for example, the deep water terminal also, we supply to them all the facilities, and also Rich Gas Terminal 2 in Pengerang, which is nearby to our facilities. Okay, this is the utilities facilities interfacing. Yeah, is an interface between the our function, our internal area, and also to the customer. For example, so we receive from the PAME. PAME is we receive a raw water. Yeah, raw water we produce ourselves, and from PAME they send the raw water to RWTP, which is raw water treatment plant. So we treat the water from PAME, from dam, from the scratch until we produce the treated water for plant usage. And also for PCP, Pengerang Power, RGT is a rich gas terminal. PDWT is a deep water terminal, and ASU. So we are interface between each other until we send to the users. Yeah. Okay, scope of work for the package 14, which is I mentioned earlier. Package 14 is for utilities and facilities. Okay, for scope of work of this package is EPCM mode. EPCM, engineering, procurement, and construction, and maintenance package include the engineering. Until we come out with the UIO facilities, is the overall facilities. So these facilities include the production and supply of the following utilities to users inside rapid complex. For example, emergency power is a diesel driven engine, and also generator. So we have air system, fuel gas system, cooling water system, and demineralized system, water system, and fire water system. So all the comprehensive system which we have to ensure all the system ready and reliable all the time to ensure the overall rapid production is in good condition. Okay, these are another scope of work, interconnecting of the process and utility stream between the various facilities within rapid, complex, and the third parties. For example, for general interconnecting system, interconnecting between the petrochemical complex, because as you know, this integrated plant, rapid plant, is integrated system. So not like in previous design, for example, in Kerteh, we have the different unit. So, but here we are in one area, and we are interconnecting between each other. And stormwater drainage system also, we have a full system throughout the rapid, effluent collection and outlet system, fire water network, and so on. Okay, for electrical and instrumentation facilities, such as high voltage power distribution, 275 kilowatt and 33 kV cables, transformers, and switchgear to supply power to all the units. Okay, then we have also electrical network monitor and control system and telecommunication towers. This is to ensure all the communication between the facilities are monitored. And this is another scope of work which is fall under package 14, all the building and substation, main laboratory building for the product analysis and so on. Also, we have the workshop and maintenance workshop. It's a sharing concept between the Petronas utilities and also Refchem. Refchem is a joint venture company between Petronas and Aramco, also in Rapid. Okay, we also have the warehouse building, chemical warehouse building, and ISO container shelter. So this warehouse is a fully integrated system, fully automatic system to handle all the petchem products until we send to jetty for the exporting. For other unit is a central emergency fire station, fire station. Also, we have the complete system inside the rapid, satellite fire station and gatehouse building. This is a utility area plot plan. So you can see here so many plot plan here based on unit by unit. You can see from the top from unit 4,000 until to 6,150. So it divided between the system and subsystem, and between this system is interconnected in between each other to get the overall process flow. It's quite big, and to manage these all utilities is a very challenging environment to us. Okay, these are utilities demand and design philosophies. Yeah, for utility HP steam from PCP. Yeah, from PCP, we are producing about the design capacity is about 1250 ton per hour, 1,250 ton per hour, and the power we have, I mentioned just now, is about 1,400 megawatt, and the power produced from PCP, and some of the about 600 megawatt we send to TMB. We're selling to TMB as our product. For raw water treatment plant, to supply treated water. So this capacity, design capacity is about 10,602 ton per hour. So we have pump 9+2 unit. For instrument air, we have about 149,250 normal meter cube per hour. So we have 5 unit of air compressor to produce the air, and 3 is driven by steam turbine and 2 by motor driven. And also we have the LP nitrogen, HP nitrogen from ASU, and fuel gas system is about 52 ton per hour. Natural gas and treated water is about design capacity is about 316 and 580 meter cube, and treated water to the M plant SP. Also we have this capacity. So this total number of utility demands and design philosophy in a utility plant. Okay, these are some of the raw water production, service water, potable water, cooling water system. So the design capacity is okay. This is quite big. Yeah. So for water production is about 15,600 meter cube. So running with 4 pumps. Yeah. 2 running and 2 standby. And also we have a cooling water system. Cooling water utilities we are supplying to customer is about 5,790 ton per hour for cooling water system. This is for cooling to all the production, including the exchangers, pump, mechanical seal, and so on. So this cooling water also we send to PREFCAM, PETCAM, yeah. So about 60,171 ton per hour. Yeah, we supply to them. Okay, sorry. Caustic and chill water. Yeah, chill water. So I don't have this deleted. And emergency power system. So we have 17 EDG set. Yeah, this is to standby during the emergency time. During emergency time, if we have no power supply from the PCP, so we have the 17 unit. EDG will take over. The plant, the power, just to sustain the plant production, yeah, to continue running. This is the steam generation and distribution system. Yeah. So as you can see from here, so from PCP is from cogen plant. So we send the high pressure steam to all the refinery, yeah, petchem, steam cracker complex, and also petrochemical complex, which is C4INA. And the excess steam, LP steam, so we send to the recovery condensate. And for your information, for the excess LP steam also can generate the money, can give a saving to the company. And last year we are embarking a new project. We installing a condensing turbine to get the excess LP steam, and we can generate more power from there, about 16 to 20 megawatt power. So these are some of the process description, on the steam distribution to user up to battery limit. So for generation, we have 3 level of steam pressure. So we have high pressure primary source from cogen plant, and we have secondly we have medium pressure and low pressure internal generation from process boilers and steam turbines. So balance demand via letdown station. And distribution area is a centralized steam distribution from centralized utility facilities steam letdown system to users. And reliability, most of the design, we design based on N+2. N+2 means N is numbers of equipment running plus 2 standby at all time for overall rapid steam system. Primary source from PCP with N+2 reliability. This is to ensure the plant all time reliable, yeah, able to supply the power and also the steam. This is the heart of the plant. So if we have shortage of power and steam, so the rapid plant won't provide as intended production, which is 300,000 barrel per day. So the other area is HP steam is also self-generated and distributed internally by SCC, steam cracker plant. They are also producing the steam, and excess steam recovery system. We call it a 3R. So this is a steam generation and distribution system. So this just to show some of the layout of the cogen plant. So we have auxiliary boilers, yeah? We have the cooling towers, and also we have the gas turbine for this unit. Okay, this is a steam associated facilities, boiler feed production. Some of the figures, yeah. So this boiler feed pump. So from boiler feed pump, send the boiler feed system condensate to refinery, and for their process, for the internal process. So these are steam associated facilities condensate recovery system. So this recovery system from the steam that we use and the low steam pressure will come out from the system will use for the other process. For example, the low steam pressure process, you know, exchanges and so on for the plant process. And this process description. So I just share with you just now on the key area, the scope, generation, distribution, reliability, and others. So I just share with you just now on the boiler feed system. So it's same. For main pump, for HP pump, MP pump, we have two standby at all time. For the main one. For the less critical one, we normally put one as a standby. So this is a condensate recovery system. This is a natural gas, a fuel gas, and pilot gas system. So actually, we received the fuel gas system from Rich Gas Terminal 2, which is also from Petronas, Petronas Gas Berhad, that's supplying all the fuel gas to PRPC UF, which is UF facilities. And this fuel gas normally we use for the cogen plant, to run the main gas turbine there. And also we send the fuel gas also for refinery, RC, and also extraction unit, SU. Okay, this fuel gas system. It's a cooling water system. Okay, for cooling water system, the treated water storage we send to refinery for cooling tower, and also for CUF cooling tower for circulation rate for about 5,000 something, and also we send treated water to SCC, the steam cracker unit for cooling tower system. And also for petchem, so we have escalation rate quite high, about 61,000 meter cube per hour. And also we send also to PCP and ASU for cooling tower system. So it's some of process description. So the same. This one a cooling water system. So many cooling water system in our plant. So again, this is from 4720 cooling water system. It's a different unit. So we have all the package here. It's a cooling water system package. We have a steam system refinery. We have a cooling water pump system, and all the changes inside the package. So this overall water system, overall scheme. So you can see from here, from the raw water, it come to raw water treatment plant. So we produce the water, we filter, and we treat the water until we can use as a processed water system. Okay, it's a water system. Again, this is an air system. We are producing the air through the air compressor package. We have 5 numbers of compressors, 3 running with steam turbine driven, and 2 with motor driven. So from the air compressor package, we compress the air and we send to the dryer package for the drying, and also we send the product to plant air system. Plant air and also to process air. So the design features here is a classification into 2 categories. One is instrument air, process air, and also plant air. So same quality of process and plant air, only differentiate by shading clarity. This is a term of process parameter. And also we have double header at generation site, and ring main concept for distribution for uninterrupted operation. So this is also the heart of the plant. So without the air system in the plant, so the plant won't run as intended design and philosophy. So this is also the critical area of the plant production. This is an overall overview of the plant air system. So we have air compressor turbine. So you can see We have 5 units. We have receiver, air receiver, instrument air receiver. We have air dryer package and also the pipe rack for connecting between unit and other unit. Okay, this utility area 2 water system. Yeah. So many system in our plant. Okay, petchem cooling water, petchem cooling water system. So this unit basically we send the cooling water system. These are all the pumps. We have about six unit of pump to send the cooling water to petrochemical complex. Yeah. This is a general interconnecting area. So you can see from the video, you can see from the slide. So the huge numbers of piping system and interconnecting system between one plant to another plant. So very, very big. Yeah. These are some of the admin building in our area. So we have the main control building, which is MCB, and we have the laboratory building, which is all the products being analyzed and set all the process parameter or process output. So this lab is very important to produce the end result to customer. And also we have the warehouse building to store our spare part, to store our components or process procurement building, which is which located the procurement team. Yeah, so they are the frontliners for us. Yeah, for the users to procure all the material and all the process bidding and so on. So another one is the centralized maintenance workshop. So this centralized maintenance workshop also very big to cover for rapid. And this we share between the Aramco and also the Petronas to share the common area for maintenance purposes. So this is some of total estimated quantities. Yeah. So you can see a very big plant and also very big area for rapid. So you can see the numbers. The numbers. So it tell you everything lah on the capacity, on the size, on the challenges, and so on. Yeah. So I think that's all on the package 14 and also the utilities facilities area, which I'm covering now for the overall plan, availability, and also reliability to ensure the supply products, utilities to refinery and also petchem uninterrupted. Yeah. So I'm right now I'm handling about very less manpower. Under me is about 20 manpower is under myself to take care all these facilities. Very, very challenging. I think that's all. Thank you.
Thank you so much, Engineer Ismail, for sharing your presentation and video. I can see a very huge facility that you have to taking care of. It's a between 7 kilometer by seven
Yeah,
kilometer.
7 kilometer by 7 kilometer. Very, very
Yeah,
big.
so big. Then we can see how the place, the area being developed. Yeah, from nothing to
Yeah.
everything today. I could say that.
Yeah, from
Yeah,
nothing
Engineer
to
Ismail.
everything. Yes, yes, Prof. Yes.
Yeah, yeah. Something that very interesting throughout your the making of this rapid plant, you share a lot of experience, but can you share is one or two the most challenging experience facing yourself during the making of the rapid plant? So we'll inspire others. Yeah.
Yes. So very interesting question and very challenging also to answer that question. Very tough to me. I think in rapid itself, I don't want to talk more about the previous experience in other place. Yeah. In rapid itself, when we trying to make up the plan, to commission the plan, right to the intended design capacity, we are facing a lot of challenges, during the construction and also during the commissioning time. One of the things that I can recall, for example, the engineering and consultancy services for us, we are, for your information, we have so many expertise in our plant. For example, from OEM, original equipment manufacturer. We have also internal expert, from group technology solution. But during the plant startup and pre-commissioning is the most critical part to us. Can you imagine, to start steam turbine in one shot, about 17 to 20 unit, it's very, very challenging, even though we have support from, like I said just now, but the challenges that we have to face through during the startup is different on paper and also on the real situation. It's much different, even though we have so many experts there. So I'm the one that together with my team, I would say we cannot sleep at night. We have to start in 2 months time. We have to bring up the plan. We have to bring up the plan.
Nervous, everything, emotion.
Yes. Can you imagine when you start a one steam turbine, then it cannot reach to the speed limit. So it trips to major reason, due to many reasons. For example, due to vibration, due to process upset, due to equipment not meeting the specification. You need to resolve immediately. Immediately you need to resolve. So sometimes we cannot depend on OEM, because OEM Petronas paid them to stay here to help us to commission. But as I said, for package 14 that I mentioned in the slide, we commission ourselves. We commission ourselves, the commissioning part. That the overall contract strategy. So the commissioning part, we do it ourselves. That the most challenging time. Can you imagine, Prof? You cannot start unit by unit due to vibration. So a lot of engineering and support. We have to dig out. We have to correct during that time. For example, so one of the example, the machine trip due to vibration, and we try to find the root cause, immediate root cause, but we could not find that time. So it comes the engineering tool. Engineering tool very much help us. For example, model analysis. For example, operational deflection, the operational deflection shape. So we take the vibration data from each of the everyone equipment, and we analyze. Based on the vibration signal, the body plot, the orbit plot, we can see. For vibration analysis, for mechanical area, they understand. The orbit, so on.
Control system.
Yes, the control system, the control narrative, all we need to change. Even though we have a full set of engineering document, but when come to the real situation, we cannot follow. Sometimes we cannot follow the control narrative. We have to change immediately at site. That come the true challenges during the commissioning time, Prof.
I believe the most difficult part is to find the root cause of the problem, because something affect by the others, but there must be something the root cause of the problem is to find it very challenging. I could understand that. Looking at that, the importance of fundamental theory. So how, you can share with some, maybe a lot of students viewing
Yeah,
our program today. So
yeah,
my question is theory into practice, because in class lecture the student believe all the theory, but how to make them actually feel ready they go out to practice? Do you have any advice or something that can share tips to them, Engineer Ismail?
yes, bro. Very, very good question. Very, very tough question to me to answer your
Okay.
question. Because when you at the student time, you
Yeah.
learn so many subjects. For example,
Yep.
you learn about strength of material, you learn about
Fluid
thermodynamics,
mechanics,
you
fluid
learn about
mechanics.
fluid mechanics, but you don't know how to use it.
Yeah.
We don't know how to use it in the real life. But here, I would like to tell you all. So the fundamental of the, for example, the thermodynamic, for example, yeah. If you have some knowledge, the basic knowledge of the thermodynamic system, then you can explore more excite, in terms
Yeah.
of temperature, in terms of pressure, how it does relate to the process system,
Yeah.
yeah.
Power
This
cycle.
yes, the operating parameters and so on.
Mhm.
But when you have some basic knowledge in school, in college,
Yeah,
you
in
only have
college,
maybe
university.
10%
Yeah,
of that
only
knowledge.
10%.
And only 10%. And after you join the industry, after you've been you work at industry, for example, and then you become a engineer, for example, to troubleshoot a problem. So a lot of things you need to consider. Not only the
Yeah.
basic fundamental, but the other factors, for example, human error, for example. So that
Yes.
one most critical part in the industry,
Mm-hmm.
and that's why. So your leadership is everywhere,
Yeah.
It's not your boss, It's your leadership actually,
Yep.
So from fundamental, to dig out the problem, to find out the root cause analysis, to find out
Yeah.
the root cause for specific problem, you have to get
Yeah.
experience, you need to learn from others also, from other places. So
Yeah.
so by blending these the basic knowledge that you have in university and also experience, you gain back experience outside, at industry, you become more opportunity to growth in the future. So that kind of combination that I would like to tell you all. Is a combination of
Yeah. Yeah.
fundamental to the experience. Yeah, bro.
Right. So yeah,
Yeah.
interesting. Yeah. When you did mention about the human error, yeah. So the problem, the issue can also comes from the human error. There comes the, what we call it, safety and health, occupational safety and health, right? So can you share with us how intense, how Petronas implement this, occupational safety and health during the making of the rapid plant, Engineer Ismail?
Yes, thank you, Prof, for the question. Yeah. So the third question, also very challenging. So I would like to tell you, at one time, the total workers in the plant, during the construction
Mm-hmm.
time is about 60,000 at the peak time, more than
Yeah.
60,000 people at site. Yeah. So how you can imagine, uh,
Mm.
so many people, so many fabrication activities, so many packages inside the plant, and so many vendors, So
Yeah.
macam-macam is all
Yeah.
over the world. You can
Yeah.
see from the pictures. How do you manage this? How do you manage this? this will become a very, very tough challenges to the management, to the project management.
Yeah.
Yeah, how to control this. Yeah, one of the thing is the important role. Yeah, is a network, is a joint venture. Yeah, with the local authority, with DOS, with DOE, and with the internal security system. Yeah, and also we have the permitting system. Yeah, to ensure everything that we have do in the plant, we have execute in the plant, follow the safety standard. Yeah, in fact,
Yeah, to
inside
follow
our
the safety
plant,
standard.
yeah, in fact, in our plant, there is a traffic track, you know,
Track, yeah.
yeah, traffic
The
camera.
plant is very big. The plant very big. Then you have traffic.
The plant is very big. How you want to control the speed? Yeah, if you're some workers, you know, driving the vehicle, how you want to control? It's about 60,000 more, yeah, people inside the plant at one time.
Yeah.
So can you imagine if you have only manpower on the old system to control this, it will not workable. Yeah? So we have combined the technology and also the cooperation between the security system and so on, that become more safer and safer to us during construction.
Yes. It's
Yes,
really a
that-
success story. You can maintain the safety and health occupational within that very big, huge area.
very big.
Right?
Yes, yes.
Engineer Ismail, I have one question from
Yes, bro.
Prof. Nasir Tamin. I think you know him,
Oh, yeah.
Prof. Nasir Tamin.
Yeah, I know him. Yeah.
Actually,
In fact-
he WhatsApp me. He has some question to see what he WhatsApp me. So I can probably I can read the question to you. Yeah.
Yes, can go.
Yeah.
Please,
So
please.
his question is, what does your team constitute of in terms of their background to handle the task that you have described? What does your team constitute of in terms of their background to handle the task that you described? Yeah.
Your voice breaking, bro. Breaking.
Oh, sorry. Yeah. The question is, what does your team constitute of?
Constitute of, okay.
Yeah. In terms of their background to handle the task that you have described.
You mean the between the Petronas management team and contractors?
Yeah.
How we
They handle.
handle this? How we embark into this? I would say a big team, for example.
Yes.
Yeah.
How to handle.
Yeah.
Compared to their
Only.
background.
Yeah. I thank you to all my my good leaders lah. For example, Dr. Colin Wong, the CEO of Rapid Plant. Yeah, so they are the giant, the leader of the the team. Yeah, that ensuring that our team is delivering and successful in constructing all the project, interconnecting between each discipline and so on. So only one thing I think I can remember lah from our leaders. One team, one goal. One team, one goal. One team, one goal. Even though you are from different discipline, for example, you are from piping side, you are from project side, you are from owner side, you are from contractor side. So all the team too inside the project team, we only introduce that statement. One team, one goal. So you can see everywhere. Putting that logo. So by putting that spirit, in terms of leadership, in terms of guidance and so on, this actually very tremendous result for us. So everybody focusing and delivering their task according to the scope of
their expertise, their background, constitute
yes,
to do one
yes.
team, one.
One team, one goal.
Yeah, yeah.
Yeah,
Easy said then done actually, but the
yeah,
person, the team that can done it, I can give thumbs up. Yeah, big thumbs up. Yeah, maybe 2 thumbs up, right?
yeah, bro. We can
Yeah,
give
yeah.
to yeah?
Yeah. Thank you so much, Engineer Ismail. I think we
Yeah,
are
yeah.
running out of time.
Sama-sama,
I know
bro.
that we have so many things to discuss. Later we can have a chat and maybe we can do more webinar program like this. Is to benefit to the students and to the public community, because not many people know about the Rapid project. Not many people about experience or appreciate the huge
Yeah,
of
yeah,
project of the Rapid,
yeah, yeah,
how
yeah,
this Rapid actually change
yeah, yeah,
our country landscape and then the economy, things
yeah,
like
yeah,
that. So maybe we can share it in the future. Yeah, Engineer Ismail. By the
yeah,
way, thank you so
yeah,
much for your
yeah,
insightful presentation and video sharing with us.
yeah,
So it is a great pleasure to have you today as a special speaker, despite of your very busy time and schedule. Yeah.
yeah,
Yeah. So do you have
yeah, bro.
something to say to our audience, Engineer Ismail, before we end this program?
Yeah, Prof. I would like to say thank you to UTM, yeah, giving me the opportunity to get closer to UTM family, for example.
Yeah.
Maybe, yeah, and
Yeah.
maybe to outsiders also, yeah. So this is, I want to say this, yeah. Since this rapid plan, yeah, very close to UTM, for
Yeah.
example,
Mm.
yeah, to UTM, the main campus, yeah. We are here, we open the door to UTM, particularly, yeah, in this area, to work together with tenaga pengajar, with the lecturers, with the student, and you are open, yeah, to contact us, to join us, to work together through a good collaboration between Petronas, Rapid, and also UTM. We can benefit each other, yeah, because this facility is the world class facilities,
Yep.
yeah, world class facilities very nearest to UTM,
Very near.
yeah, very
Yes.
close to my previous university. So come to us, and we also need you all, yeah, to help us building the capability to our country. Yeah,
Yep.
I think that's all, Prof. Thank you very much, Prof, for the
Yes,
opportunity
everybody, a
to be.
great invitation. So I
Yes,
can see a great collaboration between Rapid and UTM. We are close by. So to other viewers, to the lecturers, to the researcher, to student, don't wait. This is your time. Yeah, grab for it.
yes,
Yep.
yes,
Yeah.
yes, yes.
Okay, thank you so much. So then for our viewer, please don't forget to like and share this program, and then be yeah, for this COVID pandemic, I hope that everybody can stay safe, stay healthy, because we need to progress from time. Also, we have some restriction, but we still need to progress from time to time. So to all, thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Sampai berjumpa lagi. Bye bye. Yep.
Waalaikumsalam warahmatullahi taala wabarakatuh. Bye bye.
Bye.